Hello everyone, and welcome back to another GIS mathematics tutorial video. And in this video, I want to walk through how we can define an ellipse using a mathematical framework or an equation. Right? How can we take this sort of geometric approach that it is, all points that are a standard sum distance between two foci, right? How can we represent that geometric definition in an algebraic framework? And I want to approach this by actually deriving the standard equation of a horizontal ellipse using the distance formula. And so what we're going to do is we're going to define a couple of things, and we're going to use those definitions to create an equation that will hold true anytime an ellipse is wider than it is tall, or what we call a horizontal ellipse. So the first thing that we need to know about is, in this particular case, just to keep everything easy, right, we're going to have this ellipse be centered at the origin. Right? That means that the center of the ellipse is 0, 0. That's one definition that we need to be aware of. And all we're going to do is we're going to take into account 5 points. The 2 vertexes, which again are along the major axis, the 2 foci, which again are along the major axis, and then some point. And this point could have been any point along the ellipse. I just chose this one. And then we're going to take into account the distance between this point and both foci, which I've labeled D1 and D2. So let's go ahead and walk through a couple of definitions here. First off, the point that we've sort of picked arbitrarily, we're going to give this an algebraic set of coordinates, x and y. And I'm doing this to emphasize that this could have been any point that is on the ellipse, right? It doesn't have to be just this point. So we're going to sort of generically call it x and y. Okay, hopefully that makes sense. The center we already know is 0, 0. So I want to define 2 more sets of distances. The first is going to be this distance here from the center of the ellipse over to the positive vertex, right? We're assuming that this direction is positive in the x. So the distance from the origin to the positive vertex, we're going to call that distance a. Right? And so similarly, right, the distance from the center to the negative vertex, right, we're going to call that distance negative a. That's one definition. The other definition is this distance here from the center to the positive foci. Right? This distance here, we're going to call this c. And the distance from the center to the negative foci, right, this distance is going to be negative c. Right? And because the foci are along the x-axis, right, this distance is literally just the distance along the x-axis. Right? We don't have to account for any Pythagorean theorem or anything, or any Euclidean distance formula or anything like that. Right? Because we're on the horizontal line, this distance from here to here is just, we're going to call that c. Okay, so what we can do here is we can then use those distances to give these points coordinates. Right, so the positive vertex, right, we've defined its x coordinate as a, right, because that's the distance from the center to the vertex. So its x coordinate is going to be a, right? And because we've said that this is centered at the origin, we know that the major axis in this case is also the x-axis, which means that the y coordinate of this point is 0. And again, the y coordinate is 0 because the major axis is the x-axis, because we're centered at the origin. On the other side, right, this would then be negative a comma 0, right, because we've gone in the negative direction. And then the foci, the same sort of thing. We can label this one as c comma 0, and we can label this one as negative c comma 0. So hopefully that makes sense. We've laid out the definitions. I think what I'm actually going to do is I'm actually going to stop here before we jump into the algebra and just let these definitions sink in and where they're coming from. All right, where x and y are coming from, d1. Actually, before we do that, let's do one more set of definitions. Let's define you know what? No, let's not do that. We're actually going to end the video here. And I want to allow these definitions where A and C, X and Y, where all of these come from, I want that to sink in before we move on to actually using them algebraically to define the equation of an ellipse. So hopefully all these definitions made sense. If you're confused about where anything came from, I encourage you to go back, rewatch this video, maybe rewatch the previous videos. And as always, please reach out. Thank you.